Yes. Good evening, one and all. So, in this particular mass spectrometry class, we are going to discuss about how isotopic peaks are going to be get influenced by variable elements. So, in your previous class in mass spectrometry, we discussed about types of ions, especially from molecular ion, fragment ion. After fragment ion, we learn even electron ion, odd electron ion, and how the M by Z values are going to be calculated with the help of corresponding ions. Later on, we learn about what is isotopic peak ion. So generally, isotopic peak ions are produced by isotopes. Two types of isotopes are there: lighter isotope, one more is heavier isotope. In order to calculate M by Z value of any particular atom in a molecule, we are going to use only lighter isotope M by Z value itself. Okay. So today, in this session, we are going to discuss how M+1 peak intensity, that is isotopic peak intensity, is going to be related to molecular and peak intensity. Okay. With respect to corresponding elements, some isotopic abundance values are given from carbon, nitrogen, hydrogen, etc. So based on that, one can identify what is the peak intensity of M+1 peak as well as M+2. Okay. So keep heading. See. Isotopic peak intensity. So how to calculate isotopic peak intensities in mass spectrometry? Isotopic peak intensity. Generally, isotopic peak intensity depends upon two factors. First factor is, so what type of abundance is there for heavier isotope, and one more, how many such elements are present in given molecule. So the two factors will decide the isotopic peak intensity with respect to molecular and peak intensity, if molecular and peak intensity is assumed as 100%. Okay. Now this intensity we are comparing with every time molecular ion. Now we can write like this: isotopic peak intensity depends on two factors. It is depends on two factors. So first factor. So what is the natural abundance of heavier isotope? First one, natural abundance. Natural abundance of heavier isotope. So for a heavier isotope, what is the natural abundance? Suppose if I take C13, 1.111, okay, and if you go through hydrogen 0.016 like that, so what is the natural abundance of heavier isotope that should be taken? Heavier isotope, not lighter isotope, because always lighter isotope is taken as 100%. Okay. Next is second factor, number of elemental atoms. How many such atoms are present in a given sample? Two factors we need to remember: natural abundance of heavier isotope, and one more is number of elemental such atoms in a given sample. Suppose here C13, just you take C13, here what is the natural abundance of C13? How many C13s are present in a given sample? Suppose nitrogen, natural abundance of nitrogen, how many such nitrogens are present in a given sample? So these two will play an important role in calculating isotopic peak intensity. So generally, isotopic peak intensity calculated by M+X value. So where X is the difference between lighter isotope M by Z value and heavier isotope M by Z value in a molecule. So most commonly, we will get M+1 as well as M+2 peaks. These two are most common. M+1 as well as M+2, they are most common peaks if you compare lighter isotopes in this one. Okay. So especially for M+1 peak, M+1 peak, a contributing elements are present, such as M+1 peak, carbon, hydrogen, then even nitrogen, nitrogen 15, oxygen 17, sulfur 33. So these are the elements which are contributing for M+1 peak intensity. Because C12 is there, H1 is there, N14 is there, O16, S32. That abundance is, I am assuming, as 100%. Difference between 12 and 13 is 1. 1 and 2 is 1. 15, 6, 14, 1. 16, 17, 1. So I can take original molecule having less one value. So this is C12, H1, nitrogen 14, O16, S32. So they are lighter isotopes and this is heavier isotope. this is contributing. This all elements are contributing in calculating m+1 peak intensity in relation to molecular ion. Remember one key point. So we are calculating this intensity with related to molecular ion only. We are not calculating alone. Without assuming that molecular ion intensity is 100%, it is impossible to calculate m+1 peak intensity within the sample. Okay. So here I can write one formula. Percentage of m+1 peak in relation to molecular ion peak. So what is the percentage of m+1 peak in relation to molecular ion peak? Okay, so which elements are contributing? So first one, number of carbons multiplied by its abundance. Carbons nothing but heavier isotope, m+1. C13 here, this is C13. So what is the natural abundance? 1.11 plus here number of hydrogens multiplied by 0.016. Okay, then plus this all values we need to add. Okay, number of nitrogens multiplied by 0.38 plus number of oxygens, it is multiplied by 0.04 plus number of sulfurs multiplied by 0.78. Suppose in that particular molecule, if this sulfur is present, we need to multiply with sulfur and this value. If nitrogen is there, multiply with this. Oxygen is there, multiply with this. Means these all are heavier isotopes. Okay. So these all are m+1 peak intensity contributors. m+1 peak intensity contributors. So if you want to calculate percentage of m+1 peak intensity, we need to add carbon with corresponding abundance, hydrogen with abundance, nitrogen. This all we need to be assumed. Suppose if elements are not there, only whichever elements are present whose heavier isotope abundance will be multiplied with corresponding number of elements. So this is a formula. So most commonly, suppose if I take a molecule of formaldehyde, first you take down this. Isotopic peak intensity depends on two factors. First factor is how many elements are present, what is the natural abundance of that elements, these two factors. Then generally isotopes are represented by m+1, m+2, normally X. m+1 contributors are this element. So now this peak intensity depends upon molecular and peak intensity. So we can calculate percentage of m+1 peak by adding these elements and their abundance. Okay, suppose best example I am taking a formaldehyde, HCHO, formaldehyde. Suppose I want to calculate percentage of m+1 peak. Here this is percentage of m+1 peak is equal to how many elements are present here? Only carbon. Number of carbons multiplied by 1.11 plus number of hydrogens multiplied by 0.016 plus number of oxygens multiplied by 0.04. And if you calculate percentage of m+1, here how many carbons are present? Only one carbon. So 1 into 1.11 plus 2 hydrogens, 2 into 0.016 plus 1 into 0.04. So overall if you calculate, you will get 1.182. So with respect to molecular ion, peak intensity is only 1.182. But if you compare in this 1.182, generally maximum contribution belongs to carbon only. So contribution of hydrogens and oxygens are almost all negligible. See 1.182 here, already 1.11. So which indicates that Whenever if any molecule carry only carbon, hydrogen, oxygen, remember, generally we can ignore hydrogen and oxygen abundance within the sample and we can use only number of carbons multiplied by heavier isotope abundance, that is 1.11. So finally I can say that if any molecule carry, you remember this point, if molecule carry carbon, hydrogen, oxygen, if any molecule carry only carbon, hydrogen, oxygen, so I can say that neglect hydrogen, oxygen abundance. You need to neglect these two abundances. Hydrogen, oxygen abundance will be neglected. So means only carbon is a real participator or real contributor in order to calculate M+1 peak intensity. We can ignore hydrogen, oxygen contribution because whose contribution is very less. If contribution is very less, we can ignore that corresponding elements in calculation of M+1. So this is M+1 peak intensity calculation for this particular question. So in this carbon, hydrogen, oxygen is there. Most of the organic molecules are the common constituents of carbon, hydrogens, nothing but hydrocarbon. So while you are calculating isotopic peak intensity M+1, so simply remember, ignore hydrogen abundance as well as oxygen abundance, only carbon abundance has been used to calculate M+1 peak intensity. So now if molecule carry carbon, hydrogen, oxygen, only carbon contribution is required for M+1 calculation, so we can ignore hydrogen as well as oxygen. So based on this I can say one key formula to calculate M+1 peak intensity. See, finally percentage of M+1 is equal to number of carbons multiplied by 1.11. So this formula you need to remember. It is a most important formula in mass spectrometry. M+1 peak intensity gives information about how many carbons are present in a given unknown sample. This is a key point. How many carbons are present in a given unknown sample. So this formula is very, very important. Percentage of M+1 peak intensity, if you know, you can calculate how many carbons present in a given sample. One more. If you know number of carbons can be calculated. Percentage of M+1. If you know the M+1 peak intensity divided by 1.11, we can calculate number of carbons. This is one more formula. So what is the formula to calculate number of carbons in a given sample? Percentage of M+1 by 1.11. In this M+1, some hydrogen, oxygen abundance is there. That is 100% hydrogen, oxygen abundance is available, but that abundance we can neglect. Because whose contribution is very poor, we can neglect that abundance and leftover value belongs to carbon only. So with the help of M+1 peak intensity, only one point you need to remember. With the help of this, one can easily identify how many carbons are present in a given unknown sample. Formula is percentage of M+1 is equal to number of carbons multiplied by 1.11, and here also same. If you write this, divide by 1.11, percentage of M+1 by 1.11. Okay. So here see one question. Calculate percentage of M+1 peak in C60 bulk minister fullerene C60 molecule. You need to remember this formula. Percentage of M+1 is equal to number of carbons into 1.11. M+1 if you want to calculate, you need to use this. And if you want to calculate number of carbons, M+1 by 1.11. Now just use this formula and calculate. Calculate percentage of M+1 peak intensity in given sample having 60 carbons. So how to calculate? See this. Percentage of M+1, number of carbons is how much? 60. 60 into 1.11. So I can say 66.6. Okay, so this is 66.6 peak intensity. Means out of 100% of molecular ion, nearly 66.6% of carbon contribution is there with respect to molecular ion. So means I can write like this. See the spectra. So this is MZ value. Suppose this is molecular ion. Molecular ion, just assume that it is 100%. Suppose if molecular ion is 100%, in which 66.6%. Suppose this is 50%, above this is 66%. This is M plus 1 and here 66.6% of carbon contribution. So this peak intensity always gives information about how many carbons are present in given molecular ion, otherwise sample. So this formula is most important in order to calculate number of carbons. With the help of mass spectrometry, we can calculate number of carbons in a given unknown sample. So see this. Find the number of carbons in a molecule having M plus 1 peak intensities. I am giving N plus 1 peak intensity is 5.55. 5.55 percentage. It's only 5.55 percentage, and I would like to calculate how many carbons are present. So very easy. What is the formula? Just now I given number of carbons. See, percentage of M plus 1 is equal to M plus 1 is equal to number of carbons multiplied by 1.11. A number of carbons is equal to, just now I given this formula, M plus 1 by 1.11. What is the percentage of M plus 1 peak intensity? 5.55 by 1.11. So now the value is approximately 5. Means molecule carry 5 carbons. That is the use of M plus 1 peak. If M plus 1 peak intensity known, we can expect roughly corresponding carbons. So one or two values maybe get differ. Suppose if you are getting 60, 70 like that, on the time you may get 6 carbons or 7 carbons. But most commonly, whichever value is very closer, that corresponding carbons has been taken. 5.55 definitely you will get 5 only. Right, next, see, calculate percentage of M plus 1 peak intensity, percentage of M plus 1 peak intensity in benzaldehyde, C6H5CHO. This is benzaldehyde. What is the percentage of M plus 1 peak intensity in benzaldehyde? Okay. Suppose if you want to calculate, we know the formula, percentage of M plus 1 is equal to number of carbons, already carbons are appeared, it is 1.11. Number of carbons are C6 and here this one more carbon. So total carbons are 7. 7 into 1.11. So I can say 7.11. You will get 7.77. So that is 7.77 peak intensity. M plus 1 peak intensity is 7.77. So sometimes see they will give M plus 1 peak intensity. Sometimes they will ask carbons. Sometimes if they want to ask carbons, they will give M plus 1 peak intensity. He was asking M plus 1 peak intensity, they need to give number of carbons. So by watching the molecule, we can easily identify how many carbons are present. That if you substitute in this formula, you will get M plus 1 peak intensity. Next, so this is one more formula for percentage of M plus 2 peak. Here one more formula, percentage of M plus 2 peak intensity in relation to molecular end. So now I want to calculate M plus 2 peak intensity. Now we know M plus 1 peak intensity is contributed by carbon, nitrogen, nitrogen, sulfur and oxygen. But M plus 2 peak contributors are not carbon, because carbon never show M plus 2 contributor. It is not M plus 2 contributor. Here M plus 2 contributors are most commonly you can expect a oxygen, sulfur, chlorine, bromine only. Only these 4 elements are M plus 2 contributors. So this M plus 2 difference, molecular ion plus heavier isotope difference, if you add over here, then that will give M plus 2 peak intensity. Okay. So for this, I can write first oxygen C. First we need to write number of oxygens multiplied by 0.2. See, this is oxygen belongs to O18, not O17. It is M plus 2. M plus 2 means it is O18. How many oxygens are present? That is multiplied by 0.2 plus. Then we can also write number of sulfurs multiplied by 4.4. This is 4.4. Next, number of chlorines multiplied by 32.5. Then number of bromines multiplied by 98. So this is a formula to calculate M plus 2 peak intensity. M plus 2 peak intensity contributors are variable elements. It may carry oxygen, sulfur, chlorine as well as bromine. There is no contributing carbon in M plus 2 peak intensity. Carbon never contribute M plus 2. Hydrogen, oxygen also not contribute effectively. O17 I am saying. But this is O18 and this is 34. And what about chlorine? 37 and this is 81. So this is a formula to calculate. Suppose if molecule having only bromine is there. So now we can write the formula here like this. Percentage of M plus 2 if they carry only chlorine. Now the formula is number of chlorines multiplied by 32.5. This is the formula. Suppose if they carry only bromine, percentage of M plus 2 is equal to number of bromines multiplied by 98%. So this is 98. This is a formula if they carry only bromine. This is a formula if they carry only chlorine. Suppose if sulfur is there, other elements are absent. Sulfur if it is present. So percentage of M plus 2 peak intensity depends upon sulfur. Sulfur, right? Number of sulfurs multiplied by 4.4. Every sulfur add 4.4. Suppose if 2 sulfurs are present, 8.8 like that. These are M plus 2 contributors. M plus 2 peak contributor is this one. So best example I will show. Suppose if I take methyl chloride. Chlorine never exists M plus 1. Chlorine always give M plus 2 only. Now suppose if chlorine is M plus 2, two possibilities are expected. This chlorine will give 35. Chlorine also give 37. Okay. So if you want to calculate percentage of M plus 1, how many chlorines are present? Only one chlorine. One chlorine into 32.5. So I can say this is 32.5. Means with respect to molecular ion whose contribution is 32.5. Which means M plus 2, sorry, not M plus 1, it is M plus 2. M plus 2 peak intensity is 32.5. Okay, then what about molecular ion peak intensity? 32.5 percentage with respect to, in relation to molecular ion. Means this percentage every time we need to compare with molecular ion. Then what is molecular ion percentage? See, molecular ion percentage is always taken as 100%. So with respect to molecular ion, his contribution is 32.5. So means this is M by Z value. Suppose this is molecular ion 100% and this is only 35%. And this peak is molecular ion peak and this peak is M plus 2 peak for chlorine. Okay. Suppose second example I am giving with bromine. Suppose if bromine is present, two possibilities are expected. Bromine with 79, bromine 79, and here also bromine 81, 79, 81. And if you apply this percentage of M plus 2, how many bromines are present? Only one bromine in this one. Don't compare these two. Don't add these two bromines are present. I am taking heavy isotope. Percentage of M plus 2 is equal to 1 into 98%. Heavy isotope is 98%. Which means 98% of intensity with respect to molecular ion. So when bromine is present, this point is very, very important. Molecular ion as well as M plus 2 peak almost all same. So molecular ion peak intensity is 100%, and if M plus 2 peak is almost all, it is 98%, which means definitely molecule carry bromine. If it is 1/3 chlorine, 1:1 ratio, it is bromine. So these questions are important. So two peaks are most important for mass spectrometry. Percentage of M plus 1 peak for carbon, M plus 2 peak for either chlorine or bromine. So most commonly they are asking question from chlorine or bromine only. Okay. So if any question comes from M plus 2, think about chlorine percentage and bromine percentage. Chlorine is 32.5 and bromine is 81. This value is already given in your last class, just go through it. Lighter isotope, heavier isotope value, O16, O17, O18, 32, 33, 34. Now 35, 37, 79, 81. Chlorine, bromine never show M plus 1 contributing property because chlorine and bromine never exist in the form of 36 as well as 80. Carbon never exists in C14. C14 is not possible. Only C13 is possible. So that's why carbon never contribute in M plus 2. If M plus 2 comes, think about only oxygen, sulfur, chlorine and bromine. Almost all this contribution is very weak and very less as compared to this one. See 32 and here 98. So that's why we can ignore this 2. Sometimes even this present, you just add this and you can calculate. Next, see intensities of isotopic peaks with respect to specific elements. With respect to specific elements. Some specific elements I am taking and I am calculating m plus 2 peak intensity or m plus 1 peak intensity. Most importantly, m plus 2 peak is most important. Intensities of isotopic peaks with respect to specific element. Okay. So here we are going to use a binomial expansion. Binomial expansion formula is required for this. That is a plus b to the power n. Okay. So n is nothing but number of elemental atoms. This is number of elemental atoms. How many such elemental atoms are present? Now A is a natural abundance of lighter isotope. Okay. Percentage of natural abundance. Natural abundance of lighter. Here lighter nothing but common isotope. You need to remember this formula. Lighter isotope, common isotope, which having more abundance. N is equal to number of elemental atoms. How many elemental atoms are present? Percentage of natural abundance of lighter isotope. Now what about B? So it is almost all same. Percentage of natural abundance of heavier isotope. Heavier isotope. Lighter isotope is A, heavier isotope is B. This formula you remember. Binomial expansion requires to calculate the relative intensities of isotopic peaks with respect to one selective element. I am taking chlorine and bromine as a reference element. Then we can calculate what is the peak intensities of m plus 2 chlorine and bromine. N is nothing but how many elements are present. Suppose if molecule carry 1 chlorine, write down 1. 2 chlorine, 2. 3 chlorine, 3. Lighter isotope percentage, heavier isotope percentage. Always lighter isotope percentage is taken as 100%. Heavier with respect to lighter, heavier will be calculated. That is called relative abundance. So the two values will be written here. So you will understand by taking one example. So chlorine is the first element. Chlorine is an element which is taken here. N is equal to 1 chlorine, 2 chlorine, 3 chlorine like that. Chlorine is a atom over here. Suppose I am taking methyl chloride. Methyl chloride. So here this molecule exists in two forms. First form chlorine 35 possible and here chlorine 37 2 are possible. Lighter and heavier. If you assume as this is molecular and this is m plus 2 peak isotopic n. Now if you apply A plus B formula to the power n, binomial expansion, here in this case n is equal to 1 and what about A? Chlorine lighter isotope abundance, 35 abundance is almost all 100%, and what about B? Heavier isotope 37 percentage is nearly 32.5. So if you substitute in this formula, this you can write like this. So this is 100 plus 32.5 to the power 1. So this you can say this is 1/3 of lighter isotope. So 1/3 of lighter isotope means I can say this is 3:1 ratio. 3 plus 1. Otherwise you can say 3 plus 1 to the power 1. And see, don't add these values, write down 3:1. So indirectly I am saying that this is 100 means in this 100, 32% is belongs to heavier isotope. Means it is 1/3. 1/3 is belongs to heavier isotope. So almost all 75% is belongs to molecular ion. So I can say molecular ion intensity is 3 and this is m plus 2 peak intensity 1/3. So finally this is the conclusion. M plus 2 and this is percentage of intensity, this is molecular ion, this is isotopic ion. This is M plus 2. So when chlorine is given, You need to write 3 plus 1, but don't add these numbers. 3 indicates out of 100, out of 4 parts, 1 part is belongs to heavier isotope, remaining 3 parts belongs to lighter isotope. So that's why I would like to take always 3 plus 1. So lighter isotope taken as molecular and heavier isotope is taken as M plus 2, etc. Okay. Suppose if I take dichloromethane, here 2 chlorines are present. 2 chlorines are present. Okay. Now in this 3 possibilities are expected. Here chlorine, lighter isotope is 35, 35. This is molecular end. And one more, this sample may carry lighter isotope and this is heavier isotope, 37. 35, 37. See, 35, 35, 35, 37 means plus 2 difference. So I can say it is M plus 2. Other possibility, this chlorine is lighter, this is heavier. And other possibility, this chlorine is heavier and this chlorine is lighter. Possible. It is also possible to extract. This is only 1 and this is 2. 2 possibilities are there. And if I take one more possibility, maybe 2 chlorines are heavier, 37, 37. So this is M molecular and M plus 2. And here if you compare 35, 35 difference between these two, this and this is 4. So I can say it is M plus 4. So this is M plus 4 peak, here M plus 2 peak and this is molecular ion. So 3 possibilities are expected. First possibility, here 2 possibilities. This chlorine may be lighter, this is heavier. This may be heavier, this is lighter. And here 2 heavier. And if you see the difference, 35, 35, 70 and here 72, 72, 74. The difference I am writing in the form of 2 and 4. Now, if you apply A plus B to the power n, where n is equal to 2 chlorines are given, that is n is equal to 2. So, if I apply A plus B to the power 2, so here the formula is A square plus 2AB plus B square. Now, we know this is 3 plus 1. I can write 3 plus 1. Lighter isotope is 3, heavier isotope is 1. Abundance, natural abundance. Heavier isotope abundance is only 1/3 of lighter isotope. So I can say directly 3 square, 2 into 3 into 1 plus 1 square. So finally this become 9 is to 6 is to 1. 9 is to 6 is to 1. This is molecular and M plus 2, M plus 4. So I can write like this. This is M by Z and this is percentage of intensity. This is assumed as a molecular ion. This is molecular ion. This is M plus 2. And what about this? M plus 4. This is 100%. Here 9 is 100%. Okay. So molecular ion peak intensity 9. This is 9. Not M by Z value. Peak intensity I am saying. See, this peak intensity 9. So this 9 from here to here, this 9 is assumed as 100%. You need to assume as 100%. Then what about 6? If 9 is 100%, 6 is almost all, it is very closer to 9. So this will be over here. It is not 50%, more than 50. So I can say this is M plus 2. M plus 2 peak intensity. Now this is 1. Means it is very low. I can write over here. This is M plus 4 peak. Okay. So this is 9 and this is 6 and this is only 1. 9 is to 6 is to 1. Here 9 is assumed as 100%. With related to this, other peak intensities has been calculated. Every time first number should be taken as 100. If 9 is 100, 6%, 1% in 9. That percentage, based on that we are adding intensities. So If in mass spectrometry, if 2 chlorines are present, you will get molecular ion and 2 more additional peaks, M plus 2 as well as M plus 4. So this value you need to remember, 9:6:1 for 2 chlorines. Now this is one more application, molecule having 3 chloroform, 3 chlorines are present. So first possibility, 3 chlorines are lighter isotopes. Lighter means I would like to write 35, 35, 35. So this is molecular ion. 35, 35, 35. All are lighter. No one is heavier. Now here I am writing, this is 37, this is 35 and here 35. See, here all are lighter, here only one is heavier. One is heavier, 2 lighter. And this is equal to this one. This is also possible. Lighter, heavier, this is 35, heavier and this is 35. Now second chlorine, out of 3 chlorines, 1 chlorine heavier, remaining 2 lighter. This chlorine is heavier, remaining 2 are lighter. And one more possibility, 3 molecules are going to come. Chlorine, chlorine and here one more chlorine. 37, 35 and this is 35. Now this is heavier. So this 3 belongs to M plus 2 peaks. M plus 2 possibility. 3 possibilities are there. 1, 2, 3. In last case you will get only 2 possibilities. This is 2 possibility. This is only 1 and this is only 1. Right. Now I am going to write 2 chlorines. If I write 2 chlorines heavier, first chlorine heavier, second chlorine heavier. This is lighter. Next one more possibility. First chlorine heavier, third chlorine heavier. This is lighter. And other possibility, 1, 2, 3. This is lighter and this is heavier. 37 and this is 37. So this all peaks are belongs to M plus 4. Okay. So if you see the difference in mass between lighter elements in a given sample and heavier elements, at least one heavier element. Heavier isotope, heavier isotope, heavier isotope. That is M plus 2. Difference is 2 between this and this possibilities. Between this and this possibility 4. Here 2 heavier isotope, 2 possibilities. This may be heavier or maybe these 2 are heavier or maybe these 2 are heavier. Okay. So this is chlorine, chlorine, chlorine and this is chlorine and this is 37, 37 and this is 37. Now this possibility is belongs to M plus 6, M plus 4, M plus 6. Total 4 peaks you will get. Molecular ion M plus 2 peak, M plus 4 and here M plus 6. Based on these peaks, we can guess how many chlorines are present in a given molecule. If you ignore this molecular and you will get 3 possibilities. 1, 2, 3. 3 means 3 chlorines. That is the advantage of this technique. Here 3 heavy isotopes are possible in this particular sample. So one molecular ion or one sample, you have 3 different possibilities. Other than this, this is a major abundance. Or suppose if you are extracting 100 grams, out of 100 grams, maximum percentage is belongs to this type. So nearly 70 or more than 70% is belongs to this type. Remaining 30, these 3 will be there. These 3 possibilities. This possibility, this possibility and this possibility. First you take down this, then I will show how to use A plus B to the power n formula. Clear? Now see the possibility. See, here I am applying A plus B to the power n. We know n is equal to 3 because in this number of chlorines are 3. And A becomes, A should be taken as lighter isotope abundance. This is heavier isotope acetone. Okay, so I can write A plus B to the power 3. Or A plus B whole cube formula. So we can write like this: A cube 3A square B 3B square A, and this is B cube. So based on that we can write like this. See, this is 3 plus 1 whole cube. So here I can say 3 cube and here 3 into 1. Okay, now this is 3 into 1 square into 3 and this is 1 cube. So finally this is 1 square, B square A, this is B square and this is A. So this is 27 is to 9 into 3, 27, and here 3 into 3, 9, then followed by 1. So this is M plus molecular ion, here M plus 2 and this is M plus 4 and here M plus 6. So this is assumed as 100%. Molecular ion peak is assumed as 100%. 27 is 100%. Now this is molecular ion whose abundance is 27 and here also it is 27 only, M plus 2. Don't think it is bromine. If you are getting more than 1 peaks, M plus 2, M plus 4, M plus 3, M plus 6 like that, on that time be careful, it is not bromine. Sometimes it may be chlorine if you are getting M plus 2, M plus 4, M plus 6, if number of chlorines are given heavily. So now here 9, this 27 is assumed as a 100%, remember. This 27 is 100%, 9 will be not even 50% here. So I can say over here. So this is m plus 4, here 1% is this becomes m plus 6. So if molecule carry 3 chlorines, you will get this kind of spectra. Mass spectra is like this. So when 3 chlorines are present, m plus 2, m plus 4, m plus 6. That is the first question to identify number of chlorines. So percentage ratio is 27, 27, 9 is to 1. This is only 1 with respect to 27. So just assume that it is 9 and this is 1. Not even this much height you will get. You will get very small height. Peak intensity is very poor. Right, next. So this is homework for you, just you calculate this. CCl4, carbon clary 4 chlorines. So 4 chlorines means roughly I am giving now a plus b to the power n. Here n is equal to 4. N is equal to 4. So here you need to apply a plus b to the power of 4. So a to the power of 4, 4 a cube b, 6 a square b square, then 4 b cube a, then followed by b to the power of 4. So use this formula and calculate the corresponding peak intensities. So generally here 4 chlorines are there. So 4 chlorines means you will get molecular ion. Here m plus 2, m plus 4, m plus 6 and this is m plus 8. Just you calculate this. Work out later. Here you will get variable number of isotopic peaks here. 4 chlorines are present, 1, 2, 3, 4. 4 isotopic peaks you will get. So that is for chlorine. Next is bromine. Now I am taking bromine as an example. Bromine. So when I take bromine, bromine 79, it is a lighter isotope whose percentage is almost all 100%. Bromine 81, heavier isotope whose percentage is nearly 98%. Bromine lighter, heavier, 100%, 98%. Suppose if I take methyl bromide, 2 possibilities are expected in this one. Bromine may be lighter, bromine may be heavier. Lighter bromine 79, here heavier isotope 81. Now if I apply a plus b to the power n, so n is equal to 1 and here a lighter isotope percentage is 100% and b it is 98%, almost all it is also 100%. So I would like to take a is equal to 1 and b is also equal to 1 for bromine because both having same abundance, almost all same. So on this case I can write the formula like this. Here only one bromine is present. I can write 1 plus 1 to the power 1. If I apply a plus b whole to the power of n, This is 1 plus 1 to the power 1. So don't add these two numbers, write down 1:1 ratio. So 1:1 ratio means it is molecular ion, and what about this? It is isotopic ion, that is M plus 2. So now you will get two peaks like this. So when two bromines are present, almost all two bromines having same intensity. This is molecular ion, isotopic ion, it is percentage of intensity. That's it. That is for one bromine. So when molecule carry one bromine, you will get M plus and M plus 2 peaks having almost all same intensity. So now take two bromines within the molecule. So second example, two bromines are present, CH2Br2. CH2Br2 means first two bromines lighter, 79, 79. And here remaining two bromines. Here two bromines I am taking, 79, 81. And here bromine, this bromine is heavier now. This is 79. And here two bromines are heavier. I can write 81, 81. So observe clearly, molecular ion M plus 2, M plus 4. Similar to chlorine only. Only thing is, here lighter isotope is 1, heavier isotope is also 1. So you will get difference in their peak intensity itself. But remaining all things are remaining same. Okay. So here if I apply A plus B to the power n is equal to 2. So I can write 1 plus 1 to the power 2. So 1 is to 2 is to 1 ratio. Means here bromine, bromine, bromine. This is molecular ion M plus 2 and this is M plus 4. So this is M plus 2, this is M plus 4. So which means you will get this kind of spectra. Here M-based value, this is molecular ion. Double, M plus 2 is double to this and this is M plus 4. Molecular ion, M plus 2 peak and here M plus 4 and this is percentage of this. So that is for two bromines. See, in case of two chlorines, you will get 9 is to 6 is to 1. But when two bromines are present, 1 is to 2 is to 1. Double the number. Always lighter isotope of bromine, heavier isotope of bromine should be taken as 1:1 only, because both having almost all same abundance. So when molecule having 3 bromines, CHBr3, bromo form. Okay. So when 3 bromines are present, we need to take 3 possibilities: 79, 79, 79. And here I am not going to write 3 possibilities now. Only one example I will write. Remaining you write, work out. This is 79, 79. This is 81. In this 3 possibilities said, middle may be 81, this may be 81. 3 possibilities. I am not writing that 3. You work out later. Next, 2 may be 81. 2 heavier, 1 lighter. Here bromine, bromine, and here bromine. 81, 81, 79. Here also 3 possibilities are there, similar to chlorine. Now, 3 are heavier. 3 are heavier, 81, 81, and here also 81. Molecular ion, M plus 2, M plus 4, M plus 6. So apply the same formula. A plus B to the power n. Now n is equal to 3. Now formula is A plus B to the power 3. Means 1 plus 1 to the power 3. Now you will get 1 is to 3 is to 3 is to 1. A cube plus 3A square B, 3B square A, and B cube. 1 is to 3 is to 1. So finally, this is molecular ion M plus 2, M plus 4, M plus 6. So you will get like this. This is molecular ion 1 by 3rd. Here 1 by 3rd. And here this one. So with respect to molecular ion, this is almost all 3 times very higher. M plus 2, M plus 4, and here M plus 6, and this is M by Z, here percentage of intensity. So same way I can calculate a carbon having 4 bromines. Here n is equal to 4. Now you will get molecular ion M plus 2, M plus 4, M plus 6, M plus 8. Here you will get M plus 6, there you will get M plus 8. Here 3 bromines are there, 3 peaks. 1, 2, 3, other than molecular ion. Now 4 bromines are there, other than molecular ion you will get 4. M plus 8 you will get. So 1 plus 1 to the power 4. Now A plus B whole to the power of 4. So I can write like this. 1 is 2. Then add this 2. 3 plus 1, 4. 3 plus 3, 6. And 3 plus 1, 4. And here 1. Like this also we can get the answer. So this is molecular ion. You will get directly. This is molecular ion and this is 1 by 4th. 4 times. Now this is almost all double. And this is 4. And this is 1. M plus 2, M plus 4, M plus 6, and this is M plus 8. This is M by Z, and this is percentage of intensity. So this molecule is very important. So based on this we can calculate like this. See, when molecule having one bromine, here this is molecular ion M plus 2, this is molecular ion M plus 2, M plus 4, M plus 6, M plus 8. One bromine is there, so you'll get 1:1 ratio. Two bromines are there, 1 plus 1 2, and this is 1. And if three bromines are present, 1 plus 2 3, 2 plus 1 3, and write down 1. This technique you can apply for bromine. Suppose if bromine, 4 bromines are there, 1 plus 3 4, 3 plus 3 6, 3 plus 1 4, then followed by 1. Suppose if 5 bromines are there, first write 1 plus 4 5, 4 plus 6 10, 6 plus 4 10, then 5 1. Like that we can keep on writing a Pythagoras form. So here this bromine, one bromine is there, there is no M plus 4, there is no M plus 6, there is no M plus 8, like this. You need to identify this. So if 2 bromines are present, 3 bromines are present, they will ask about the intensity ratio. So this year in CSR examination, these two questions are, two molecules with this question is given. See, this is this year question. 1,4 dibromobenzene is given, and one more is tribromobenzene. Okay, so these two molecules are given in CSR examination this year, and they are asking, this is December paper, this question is given. What is the isotopic ratio of these two molecules? Here 2 bromines are present, 2 bromines. What is the ratio? When 2 bromines are present, 1:2:1. When 3 bromines are present, 1:3:2, this 3:1. So this is the given in option. This is the correct answer. So for this 1:2:1, and this is 1:3:3:1. This is CSR question this year. If 1 chlorine is there, 3:1. If 2 chlorines are present, 9:6:1. 3 chlorines are present, 27, 27, 9:1. So like that, you will get the values between chlorine and bromine, but most commonly bromine they are asking as compared to chlorine. But formula remains same. See, one more example. Suppose if mixed halogens are present, here chlorine and here bromine is present. One chlorine, one bromine is present. So on that time, two formulas has been applied. 2 power A plus B to the power N, C plus D to the power M. Okay, so this is for chlorine, then this is for bromine. We need to apply. So for chlorine, I can write 3 plus 1 to the power 1, and here 1 plus 1 to the power 1. So I can say 3 plus 1, and here 1 plus 1. Then you multiply with this. 3 into 1, 3, plus 3 into 1, 3. 1 into 1, 1. And this is 1 into 1, 1. So now you will get 3:1:1. Like this we need to calculate. Now this is molecular ion. This is M plus 2 peak, M plus 4, and this is M plus 6. Okay, so one more simple, make a correction. See this, after getting this, you need to find out like this. So generally you won't get all peaks here, some peaks will be disappear. Now this is 35 and this is 79, both are lighter. And if I write one heavier, chlorine, bromine, this become 35 and this become 81. Otherwise you can write one more possibility, here chlorine and this is bromine, this is 79 and this is 37. Okay, only molecular ion, this is only one molecular ion, two lighter, and here among these two one will be lighter, other is heavier, heavier, lighter. So now this become M plus 2. Okay, and only one possibility is there where two are heavier, this is 81, chlorine 35. So now it becomes 37. So now this becomes a M plus 4. M plus 4. Okay, but what I written? M plus 6. This won't exist. So on this time what happens? See, after getting these numbers, don't write this one. So generally, if you calculate, what you'll get? 3 is to 3 is to 1 is to 1 is to 1. So these middle numbers we need to add. So finally 3 is to 4 is to 1. 3 is to 4 is to 1. Like this you will get finally. Add middle 2. So this is your molecular ion, and this become M plus 2. M plus 2 and this become M plus 4. Even if one chlorine, two bromines, two chlorine, two bromine, you need to apply first chlorine, next bromine. You multiply with this, and based on the possibilities, middle numbers you need to assemble them. Suppose if molecule having one sulfur, see this is SH I am writing. Now two possibilities are expected. Sulfur, I am taking sulfur, that is 32. Heavier isotope, sulfur. 33, 34 is also possible, but 34% is 4.4. See, M plus 2 peak intensity. 32 is 0.78 only, but 34 is 4.4. So we need to take M plus 2 peak intensity for sulfur. Right? So if I take direct sulfur, only one sulfur is present. A plus B to the power of N. Lighter isotope is 100%. You can take directly 100%. B 4.4. 4.4 and this is 1. So I can say 100 is to 4.4. This is molecular and peak intensity, and this is M plus 2 peak intensity. So I can write sulfur like this. Sulfur, if you assume this is 100%, molecular ion is 100%. And at least over here, only 4.4% belongs to M plus 2. This is CS3SH 32 and here CS3SH 34. So this is percentage of intensity and this is M by Z value. Molecular ion is 100%, this is taken as 100%. And this with respect to molecular ion, this percentage is 4.4. Remember, when M plus 2 peak is 4.4, definitely sulfur is present. So directly even you can take percentage here. Don't think that every time that fraction value has been taken. You can take direct percentage. Even for bromine also 198. That also you will get same answer. Even for chlorine also 100 plus 32.5. Even that calculations will give same answer. So this is your last example for isotopic peak abundance availability. Here sulfur and here CH3. 2 sulfurs I am taking. So this is 32, 32, 32, 34, 34, 32 and 2 34s. So here variable possibilities are expected in this one. Here 2 sulfurs are present, A plus B to the power 2. Here A should be taken as 100 and heavier isotope 4.4 to the power 2. So A square 4.4 square. Now 2AB 2 into 100 into 4.4, then 4.4 square. Okay, so here this is 100 square, then you will get 880. So this is 19.36 you will get. 4.4 square. This is 4.4 square. Square you will get 19.36. So if you divide by 100, if you want to get exact intensity of peaks, you just divide by 100 if you want to take a exact percentage. Now on that time you will get 100%, this is 100, 100 is to, so write 8.8, this is 8.8 and this is 0.19. So this is molecular and peak intensity, and this is M plus 2 peak intensity, and this becomes a M plus 4 intensity when 2 sulfurs are present. This is a peak intensity 0.19. So which means when 2 sulfurs are present, this is 32 and this is 32. This become a molecular ion. If only one is heavier, 32 and here 34, here 2 possibilities are there. Remember I am writing only one possibility, but actually 2 possibilities are present. This is 34, 32, this may be 34 and this is 32, 2 possibilities. Next, here 2 sulfurs and this is 34 and here also 34. So difference is M plus 4, M plus 4. So I can say molecular ion M plus 2, M plus 4. So if you see the peak intensities, percentage and M by Z value, now this is 100%. I am assuming as 100%. Molecular ion is 100%. In this 100%, only 8.8%. This is 100%, 8.8%, 0.19%. Directly you will get percentages here if you divide with 100. Even for chlorine, bromine also can apply the same concept. Now this is assumed as 100%. Molecular and peak is 100%. And bromine, it is, sulfur 8.8, here it is only 8.8. This becomes M plus 2. For your understanding purpose, I am writing little bit more intensively, but it is actually 8.8 means very less. Over here only you will get. Not even this percent, you will get up to here. Okay, and this is very small. This is M plus 4. This M plus 4 belongs to 0.19%. So this is M by Z value and this is percentage of intensity. So this class is most important because how to calculate M plus 1 peak intensity, how to calculate M plus 1 peak intensity, and what is the role of using M plus 1 and M plus 2 peak intensities. Every time remember, while you are writing M plus 1 peak intensity or M plus 2 peak intensity, that we are comparing with molecular ion only. By assuming molecular ion is 100%, we are writing isotopic peaks as related to molecular ion. Okay, maybe 10%, 8%, 1:1, 1:3, 3:1. Like that we are writing based on molecular ion, but actually that intensity is not that much height as compared to molecular ion. Okay, so from this area in this class you may expect a question every time. One question is asking from chlorine, bromine. So even nearly 2 to 3 times in CSR examination, bromine question is repeating. So they will ask which among the following element having a maximum M+2 peak intensity with respect to molecular ion. 4 elements are given: chlorine, bromine, sulfur, nitrogen. So which among the following elements having maximum intensity similar to molecular ion? That is bromine. So like that, very easiest questions are expecting from isotopic peak. In your CSR examination and even GATE examination, maximum isotopic peak questions are coming. So that's why we are taking much more examples to calculate all possible peak intensity representations as well as different elements, abundance nature in variable elements. Okay, so I think you have some knowledge on isotopic peaks as well as isotopic ions. So in your next class you will see what are multiple charged ions and what is molecular ion interaction ion, and one more is metastable ion, and finally negative charged ion. So almost all maximum ions are over. First we discussed about molecular ion, next fragment ion, even electron, odd electron, finally isotopic ion. Only isotopic ion it will take some time, but definitely it is the most important for your examination. So next ions are very easy. Multiply charged ion, nothing but if any molecule carry more than one charge, that particular family belongs to multiply charged ion. And if you go through molecular ion interaction ion, so this point already explained, when one molecule after losing one electron forms a molecular ion, it is going to collide with a ground state molecule, otherwise you can say neutral molecule, and that will abstract one of the hydrogen and forms a cation. So that will give M+1 peak. That is called molecular ion interaction peak. Then finally you can say metastable ion. Metastable ion is also very important one, because normal ions are generates cations with respective in their chamber. Okay, so especially that ionic chamber is there it will be generated. But metastable ion, it is going to be generated in a other than mass chamber. Okay, so double focused mass instrumentation, single focus mass instrumentation is there. So in double focus mass instrumentation or single focus mass instrumentation, especially with respect to their fields, after ejection of corresponding cations from ionic chamber, some cations are going to be entered into mass chamber, mass ionic chamber, that may be single focused or double focus. There if any fragmentation takes place, that is called metastable ion. Metastable ion always represented by a broad line, it is not represented by a short vertical line, but other than metastable ion, remaining all ions are represented by a short vertical line. Okay, so that is about isotopic ions and isotopic peaks with respect to chlorine, bromine and other possible elements. Okay, so we'll stop here. We'll continue remaining types of ions in your next class. Okay, see you in next class.